I guess you're seeing the wrong screen. Can you see the presentation or?
Yes, I can see it.
Okay, great. So hello everyone. For the people who might not know me yet, I'm Raphaël and Mila. I've been working for Mine since August last year, and specifically on prplMesh since mid-September. So I will first let Mila introduce herself, and then I'll start with continuous integration. And then Mila will tell us more about the certification itself.
Hi everybody, my name is Mila. I also working from August last year. We started to build a testbed, me and Tomer actually, and I'm continuing now. That's all.
So as I was saying, I first start with continuous integration. When Frederick first asked me to make a presentation about CI, I thought I was not going to explain the reasons why CI is important, because I thought that's something that's already widely accepted. But after thinking about it again, I thought that maybe I can still give some reasons for why CI is important, at least to me. So one of the reasons is that this is something that I think, have all heard way too many times. No matter how many efforts you put into making sure that every developer has the same environment, that everyone runs the same test suite with the same arguments and so on, there will always be cases where either the test suite is run with different arguments, or maybe it was run correctly, but a developer has first submitted a PR, a pull request, and then has changed something in between and forgot to run the test suite again. So the first reason is that people are not good at making sure that nothing breaks. The second reason I wanted to highlight is you don't want to, if something breaks, you want to know as soon as possible, and you don't want the users to figure out that you broke something a few months ago and you didn't notice. So to me, that would be the second reason. You want to catch any bug or any regression early. And then finally, running a test suite is something that can be relatively easily automated, and so you don't want to put that on the developer to always think about running a test suite, and you don't want to waste their time with that, because it's easy to automate. Now, that being said, I would also like to highlight that it's not because you have a CI infrastructure that it's okay, you're never going to have bugs anymore, of course, or any regressions anymore. And the reason for that is that it's only as good as what you define, basically. So first, is every line of code being built? It was, we had a situation in September where only one of the variants of prplMesh was built in CI, for example, and so there were large parts of the code which weren't even being built, which means that at some point your master branch doesn't build anymore, because it happens. Also, is everything tested? That's something that can be hard to have an idea of, to have metrics about, depending on what kind of test you run. And also, yes, it's not because you test many individual parts of the code that overall it makes sense and that every part works well with one another. So that's the reason why you also need functional or integration tests to make sure that everything works on at a higher level. Also, when you define a CI configuration, it of course always uses a very fixed environment, and that's something we want. Why? Because we don't want test results to be different depending between different runs on the same code. So we want the environment to be very controlled and to be always the same, or at least we want to decide if we want to do upgrades, for example. Now, it has a consequence. Of course, in reality, the environment where the code is going to be run will always be different, which means that it's always good to add variety to the environment you use in CI. And lastly, it's not because you have CI infrastructure that code reviews are not necessary anymore. The very straightforward example is that if you could say that you remove all the tests and so CI passes, but you could still catch that using by detecting coverage changes, for example. But if you also remove the code itself, then the coverage is going to be good. The CI is going to pass, but it doesn't mean that it's something that you want. So now I'm going to go over a bit more in details over what the CI configuration was before, and then I'm going to explain what changed overall. So this is the Travis configuration that was used back in September. We have a first part where the images that are going to be used for the tests are being either pulled from Docker Hub or built. There is a Clang format part which checks that the code formatting is correct. And then this part is the build itself. As I mentioned before, here, for example, it's only building the dummy variant of prplMesh, which means that the other existing BWL variants were not being built at all at that point, at least not automatically. Then there is a part that checks that the generated TLVs are up to date. There are also unit tests for the TLV factories. That's this part. And lastly, we have the test flows, which is kind of the certification test reproduced using Docker. Why is it like that? Because the certification tests from the Wi-Fi Alliance take a lot of time to run, so we need to have something that we can run more frequently. So before showing you what has changed, I wanted to mention that we had to switch to GitLab for a couple of reasons. First, because it's in many aspects more flexible. It's also not limited in time because I think Travis has a limit on how many minutes you can use it for. And we also needed way more computing resources because we are building the open hierarchy firmwares in CI, and so we need more powerful machines to do that. Which means that we needed our own runners with GitLab, which GitLab CI allows us to do. Finally, we also wanted to run tests on real devices. So I mentioned that we are running the simulated flow tests in Docker, but we also want to run them on real devices later on. And so instead of giving you the GitLab configuration file, which might contain a bit too many details to go over, this is the overview of CI pipeline. And so overall, what do we have? We still have, so first we have additional build jobs. The first three are building for the 3 different OpenWRT targets that we currently support. Then we still have the dummy Docker build, and we also have an additional one now that builds static libraries. We still have the Clang format, so same as before. And we also added a static analysis job, which at the moment is only CPP check, but we would like to add more. Regarding the tests, we still have the test flows same as before, except that it has been ported to Python in the meantime. TLV tests are the same, and we now have tests on real devices, which at the moment are only very basic tests. But I will show you the topology later, and this is what will allow us to run more complex tests, so the test flows from real devices. Are there any questions so far? Because I didn't let you time to ask questions. Okay, then let's go on. So this is, yes, go ahead.
Question. So you mentioned the certification test, and yesterday we went over several tests that are in progress and etc. So each and I know that we don't run the certification test all the time on each PR. So the maintaining of which test will be run and stuff like that is something that maybe we should run it more frequently and not just by the developers that run the certification.
So yes, that's correct. We are not running the certification tests themselves for every commit or not even every pull request. And the reason for that is that it takes a lot of time. One test is around 10 minutes, sometimes more, and there are many of them that we would like to run. So unfortunately, we cannot do that for every pull request, which is why we would like to replicate that by porting the flow test that we currently have in Docker. We would like to port that to run on real devices. And that will allow us to run those tests for every commit, and so avoid having pull requests that break other flows, for example. What we have also decided is to ask developers that open pull requests to also try to run the certification tests that they think are relevant to run, because there is no straightforward way to automatically guess what kind of test has to be run based on the changes that a pull request introduces. Does it somewhat? Okay. And so I was going to now show what's being run only nightly. And so not at every push because of time. How different is it? First, there is one more build. It's using a completely different distro with different libc and a different GCC version. We are not running it at every push and every commit, also because back then we didn't have the computing power to do that. So we thought that running it once a day would still be an improvement over not doing that at all. And this is the certification test job. So it's really running the Wi-Fi Alliance certification tests. We have a list of tests that we know prplMesh is currently passing. And every time we add new flow implementations, we add them to the list of tests that are being run. As you can see, the job here is failing, and it means that we have been having issues with the certification tests since the beginning, with the stability of the tests. So running them 2 times in a row doesn't mean that we are going to have the same results, which is a problem, but it has improved already lately.
The problems are in the tests themselves or in the code?
It depends. We had a lot of issues with the sniffer, for example, which would drop packets when there were too many of them, which means that sometimes it would drop the packets that are tested for in the test itself. And sometimes it would not miss them. So the test result would always be, would often be different. Now, there are also some specific behaviors of the certified devices which can also make the test fail sometimes, but not always. For example, the Broadcom device, if I remember correctly, has some kind of timeout. It waits for 60 seconds for something, and if you send it what it expects too fast or too slowly, then the test is going to fail. So there are a couple of reasons why the tests are not really stable. So sometimes it's the tests themselves and what's being used in the test, so the sniffer and so on, which Mila is going to tell you more about. But sometimes also prplMesh, because we have to adapt to what the certified devices, the real devices, do in practice. So this is the topology of what we have. So I'm going to quickly explain what is what. So we have a laptop that's running the GitLab runner. So this is the one that will, for every commit, get the build prplMesh and deploy it to a device and check that the controller alone reaches the operational state. And it does that for every device. And this is where we would like to run the flow tests. So instead of just using them one by one, we would like to, for example, use the laptop as a dummy controller and one of the devices as an agent, or even use this one as a controller, for example, and the other 2 as agents, or do combinations of that. So this is where it's going to happen. Are there any other questions so far about that? Okay. So what do we plan to do next in CI? A couple of things. Some of them I already mentioned. Running test flows, for example. We would also like to build the Docker images themselves in CI, because up to now, every time we need to make a change to an image that's used in CI, we have to push it manually to Docker Hub, which is not very convenient. And the same goes for the prplWRT firmware. When we want to update it, we don't want to have to compile it manually and deploy it manually to the targets. We would like that to be automated. As Mario mentioned also during his presentation on Tuesday, unit tests might be something of value to add, but more generally also functional tests, and overall, the more relevant tests we can add, the better. We would also like to split the certification test, because at the moment, it's every time a single job. So it means that it's a job that runs for 2 hours and a half for the controller certification test, for example. And so you have to wait all that time before you can get the logs of the tests. And retrying a specific test is also not very convenient because it's a single job. We would also like to add new targets, both for the certification test, but also for the builds themselves. And we also have a couple of ideas on other static analysis tools to add. So now I'm giving the floor to Mila, which will explain you a couple of interesting things about the certification itself.
Okay, do you see my presentation?
Yes.
Okay, so I will present about testbed itself. I will start from the old version of the setup, and about its components, and about some configurations, and then we'll move to the new version. Okay, so here you can see all devices that we used for testbed. It's 4 APs, Qualcomm, Marvell, Broadcom, and MediaTek, that can be used as controllers and agents. We have another Qualcomm for CTT AP. We have Marvell Wi-Fi card for CTT STA station. We also have a WTS console that drives all test executions, and we have 2 sniffers, one wired sniffer and one wireless sniffer, and 2 switches for 2 networks. We have 2 networks for data network and one for control network.
Mila, could you explain what CTT means?
Oh, no, actually. No. It's I think it's kind of part of actually, I didn't see any explanation regarding this about this. It's just used so.
Okay.
So all documentation and tutorials is available on the Wi-Fi Alliance FTP site, so you can download it. The next is the details regarding all the devices. As you can see, we need to use some specific vendor and specific model and specific software version for each of them. For Broadcom and for MediaTek, we need to use another laptop for running it's Sigma, and for Marvell and Qualcomm, no need. We don't need any laptop. Of course, for Marvell Wi-Fi card, we need a laptop with a suitable slot. Here you can see the details about Qualcomm and ASUS that used as a wireless sniffer, and information regarding two switches. For data network switch, we need to use a smart switch because there is a need to turn on the port mirroring feature on for Ethernet sniffer capture. And for control network, it can be any switch. Okay. So here you can see the topology for old version of setup. We have here two networks, all APs connected to both networks. And the main point here is to connect wired sniffer to port 1 on data network switch, because all other ports are mirrored to that port, so wired sniffer can get all packets, all traffic from them. It's a IP address scheme for old version of setup. So all we need to prepare the setup, we need to install or upgrade the Wi-Fi test suite components firmware according to its tutorial. We need to configure static IP addresses for them, and of course to connect all of them as shown in topology scheme. Next is components configuration. For Marvell and Qualcomm, we don't need any. We don't have any additional configuration file because it's Sigma is running on the device. And for Broadcom and MediaTek, we have different laptop for Sigma. So this is an example for configuration file of Broadcom Sigma. As you can see, it uses port 15,000 for its Sigma. We need
Just
to
quickly,
update.
Mila,
Yeah.
some people might not be aware what a Sigma agent is. So can you just explain that in a sentence?
Yes, actually, it's the part that should communicate with testbed with UCC. So when I run some test on the UCC console, it send some commands. Sigma get it and give it's for communication with UCC part. So here you can see the port number that Sigma uses, and interfaces name, interface name, and its IP address for control network, and in interface name and its IP that connected to Broadcom, and Broadcom's IP itself. It's for Broadcom, and this for MediaTek. So also you can see here the port number and MediaTek's IP address. Okay, so it's a configuration for wired sniffer. As I said previously, it should be connected to port 1 on data network switch, and it has all traffic that from those ports. And we need to also update, we need to edit IP address for ASUS sniffer in this file. Running Sigma, sniffer Sigma will bring two processes for sniffer agent. One will listen to port 99 05 for capturing wireless data, and in other it's 9999 for capturing Ethernet data. Okay, so next it's UCC laptop, Unified Copy Console. Here we're using it to run the test. So it has a couple of configuration files. The main it's all init config map file that contains all IP addresses for all components, and it's Sigma ports. So you can see here a section for DUT. It also has another sections for controller and for agents. So here we need to update all relevant IP addresses for all of them, for all equipment. And also we have another configuration file, master test info, that contains all possible tests and configuration for them. Here you can see that, for example, map 421 should use Marvel as a controller, and no need to an agents or STA. But we can change it. You can use another one. Okay. So also UCC contain another configuration files. It's three type of files: load DT ready info and load CTT agent 1 and CTT agent 2 that contain information contains information about which file to load, which file to use to get all RUID information for all APIs. So here an example for Qualcomm. It should use this file for Qualcomm. And the next, it's the file itself. All of APIs have three type of configuration files that contain its RUID. So here you can see an example for Qualcomm also. It's Qualcomm has 3 radios, so we need to update a RUID for them in all 3 files. So that's all for old version of setup. Okay, the next is a new version of setup. So we still have 2 networks, of course, and we have all APIs connected to also to data network switch and control network switch. But now we have just one master PC that we use it to run all Sigmas, and we have ASUS sniffer also. So regarding regarding APIs and ASUS sniffer and switches, it's the same as it was in the old version of setup. But on Marvel Master PC, we are running Broadcom Sigma, MediaTek Sigma, Marvel STA Sigma, a wired sniffer Sigma, and UCC console also. Okay, so here we need to just to change a little Broadcom configuration file, because we need to change to localhost IP, because now we have Sigma running on the same laptop as UCC. And for Qualcomm, Marvel, MediaTek, and wired sniffer, there is no changes. And for UCC, we need to update also IP addresses just for Broadcom and MediaTek and Marvel. Also, it should be used localhost IP addresses. Okay. Now I want to explain about test plan. So we have two types of tests. It's MCUT and MAUT tests. MCUT it's for multi-AP controller. We have 13 test cases and 23 test procedures. And MAUT it's for multi-AP agent under test. We have 38 test cases and 156 test procedures. Which type of test will be run? We can choose it in all init config map. Just replace MAUT with MCUT. And also, test plan has requirements regarding each of tests. For example, here you can see that for test map 421, we need to use Marvel as a controller. And for test 451, we need to use Qualcomm as a controller and Broadcom as an agent one. And if it uses Wi-Fi backhaul and if it uses Ethernet backhaul, there is no need in agent one. This is a list of all MCUT tests and MAUT tests. And according to the test plan, some tests consist of different combination of test variations. It depends on which backhaul or which combination of backhaul and fronthaul type. It's an example for Ethernet backhaul, map 431 ETH. The same test with Wi-Fi backhaul and combinations of backhaul and fronthauls. Okay, so on old version to run test, there is a need to update all init config map. I did it manually every time. So yeah, I needed to uncomment all lines of the devices that is used and comment all lines all of devices that isn't used. And we need to start sniffer and all sigmas manually, and then we can run the test itself. On the new version of Testbed, it's all done automatically by running the script like this. And we need to just put here duty name and test name. So and that's all. And I have yes, and all logs, gathering logs. It's now it's pretty easy, because all logs is collected to logs folder on master PC, and have all logs that we need. So that's all. And I want to demonstrate running some tests. So, okay. So as I said, to run any test, we need to run the script. And here you can see the Netgear RAX 40 that will be used as DUT, and it's the name of the test. So the test starts. Here you can see the.
Wait, Mila, we still have the presentation. We cannot see the.
You don't see
no, we only have the presentation.
Why?
I think you shared the window instead of your entire desktop.
Okay.
You have to stop sharing and then share again either the other window or your entire desktop.
Let's see. Okay. Share screen. Okay. Okay, now you see?
Yes.
Okay, so it's the master PC. So here, as I said, we need to run just one script with the DUT name and name of the test itself. Here you can see we use a Netgear RAX40, and you can see all output of the UCC console. Oops. Yeah, it's output of the UCC console, as you can see here. It started from dev reset default, and okay, and the test is continuing. So that's all for me. Any questions?
Yes, I have a question. The tests themselves, or the sets of the test, who defines them? Who decides what to test?
You can. Are you talking about DUT? Which device will be DUT, or what?
You showed 156, I think, tests for the procedures for the agent and more tests for the controller in few slides back. So who defines all the tests? Who decides what is needed to be tested?
We have a test plan, so it's the list of specific tests that we need to run.
Which came from?
It's from Wi-Fi Alliance.
Okay. So it's external to prplMesh.
Yes. Sorry to interrupt.
Okay. Okay.
Okay.
So it's basically the test that will be run if you want to certify a device to get the multi-AP certification. And so that's why we are doing all this. It's because we want people to be able to put prplMesh on a device and get it certified. We want to make sure that it's certifiable.
Yes, okay, thank you.
Okay, any questions? Okay, so that's for me.
Thank you very much, Mila and Raphaël. It was a very useful presentation. Yeah, please send your slides to me. And yeah, thank you very much.